Hey guys, today I'm going to teach you how to solve systems of equations using graphing. And so we're going to rely heavily on the Desmos graphing calculator website that we'll be able to access on our state assessment to complete this lesson. So if you will, before we get started, make sure you have a sheet of paper and a pencil. If you have a phone or if you have the ability to open like a separate tab on the device that you're watching this video on, open up desmos.com. And then if you happen to have some graph paper, and I realize that's kind of a stretch, but if you happen to have some graph paper, we are going to graph a couple of systems of equations today. And so it'd be a little bit easier if you had graph paper. If you don't, it's okay. You can use regular paper. But if you happen to have some graph paper, you might prefer that. So if you'll get those items together and then come back to this video, we will be ready to start. So a system of equations is two equations that have to both be satisfied at the same time to be true. So two equations together. Let's pick a different color. I'm going to highlight some things. I do want you to write these notes, by the way. And I shortened them as much as I could, but you may be like, there's a lot of stuff to write, Miss Ware. It's about as short as I could get it. So a system of equations is two equations which both have to be satisfied at the same time to be true. Meaning one equation has to be true and the other has to be true at exactly the same time for the system to be considered true. When you talk about solving a system, the solution to the system is an ordered pair that makes both equations true. So it's an x and a y that make both equations true at the same time. When you graph a system, that ordered pair is the point where the two lines will intersect each other. So when we're talking about a system, we're talking about two y equals mx plus b equations. They may not be in that order, but two equations with an x and a y in them. But both have to be made true using an ordered pair xy for that ordered pair to be considered the solution to that. And so we can find that solution by graphing them and finding that xy where the two lines intersect. If you're still writing this, just pause the video, but I'm going to go on to the next slide. So there are three types of solutions that you'll see with a system. You could have a system that has one solution. I did not mean to leave this text box in here. Hold on. Let me see if I can figure out how to delete it. Y'all may not even can see it. I don't really know. There we go. So there are three types of solutions to systems. You could have one solution. That means that the lines are going to intersect one time. The lines cross once. And so your solution to that is a point xy. That looks like this right here. So if you'll sketch just a quick little picture of that, you don't have to have all the grid lines and stuff. It can be something just as simple as you draw a coordinate plane and then you draw two intersecting lines in that. So draw a line like that, draw another one like that. Just so that I know that you know what that's going to look like for you. So lines cross once for one solution. If we were solving this, whatever point this is right here would be the solution to that system. That point where those two lines cross one another is the solution to that system. Now you could also have no solution. That means the lines are parallel, so they will never cross. So again, if you'll sketch a picture of what parallel lines look like in the coordinate plane. So just draw yourself a quick coordinate plane, draw two parallel lines that never cross. And then you could also have an infinite number of solutions. So that's a solution where the lines cross everywhere. Basically meaning they become the same line. So if your lines overlap, let me see if I can move this, I can't. Then that ends up being an infinite solution situation. So that would be something where if you had that sketched out and you had the red line gets drawn and then the blue line comes right behind it on the exact same spot. And of course I can't draw two lines in exactly the same spot with my finger like that. But that's the idea, is that your two lines overlap one another in exactly the same place. and that makes infinite solutions because they touch everywhere. So you need to be aware of that, because if you graph one of these and you get parallel lines, or you graph one of these and you get the exact same line, you want to recognize that that's either no solution or an infinite number of solutions. And remember, no solutions touch nowhere, infinite solutions touch everywhere. Okay, again, pause the video if you're not done. I'm going to move to the next slide. So here's how we're going to solve a system, and there are multiple ways to solve them. You can solve them algebraically. They're two methods of solving algebraically, and they are both really complicated. And so since we have access to this Desmos software when we take our state assessment, and since I'm trying to find some things that I can teach you from home that are not just ridiculously complicated, we're going to stick with just solving these by graphing at this time. Now, I may later on show you how to solve using the other two methods, but for now, we're only going to focus on this solving a system with graphing. So, to do that, to solve the system, go to Desmos.com, choose the graphing calculator. Type in both equations. Then you're going to have to pan or zoom, so move around the coordinate plane, zoom in if you need to, until you find the point of intersection. That point is your solution. Remember, if your lines are parallel, there's no solution. If your lines are the same, it's infinite solutions. So jot down those steps, and then we're going to go to the next slide, and I'll show you how they work. If you're not done writing them, pause the video, finish writing them, unpause, and move on. Okay, so I've got 4 examples right here on this slide, and we are not going to draw out graphs of each one, because that would be a little bit ridiculous, since we can just pull up Desmos on a separate tab to solve these. So if you'll write down all 4 of them, so just pause the video real quick, write down all 4 of them, leave yourself a little bit of space to give your answer. And then I'll pull up Desmos on my device, and you pull up Desmos on your device, and we'll look at how we can solve these using Desmos. So write them down. If you need to pause the video real quick to do that, pause it and then unpause it, and you'll see me get started with solving them. So I'm going to pull up Desmos. And I'm going to start with this very first one. So if we're going to solve this, we're going to type that in the lines here. So the first equation goes in the first line, the second equation will go in the second line. And I'm just going to type it just like it is. X minus 7y equals negative 11. So there's one line. And my second line is 5x plus 2y equals negative 18. And this is a little bit different than our normal calculators. The minus key serves as a negative key also. So if you're like, well, how do I put a negative? You just use the minus button. Okay, so I've typed in both of my equations. We'll double check and make sure I didn't make any mistakes in what I typed. X minus 7y negative 11, 5x plus 2y negative 18. Okay, so that means what you see graphed here is this system of equations. The red line is that top equation, the blue line is that bottom equation. The solution to this system of equations is going to be the point where those lines intersect one another. That's this point right here. So if you touch the point in Desmos, it tells you the ordered pair for it, negative 4, 1. That's my solution. So I'm going to come back over here to my, oh, just kidding. And they go. I don't know why that stuck to that, but okay. Anyway. Whatever. Negative 4, 1. And that's our answer. I don't know why the word example is moving along with my calculator, but I don't seem to be able to fix that, so I'm just going to leave it alone. Whatever. So then let's go to the one underneath it. 3x plus 9y equals negative 6. Three x plus 9y equals negative 6. And then negative 4x 4x minus 12y equals 8. Let me erase this. Okay, so if we look at what we've graphed here, I only have one line. And if you look, you can do this too if you're not sure what happened because you weren't necessarily watching the graph while you were typing your stuff in, which I have a tendency to do. If you touch the little colored circle next to the equation that you've graphed and make it no longer colored in, it'll make that equation hidden for the time being. It's like right now I've hidden both of them. I just touched the circle next to the 3x plus 9y, and the green equation came back. Touch the circle next to the negative 4x minus 12y, the purple equation comes back. And if you notice, those equations or those lines are in exactly the same spot. When they end up being exactly the same line, our graphs touch everywhere. That makes an infinite number of solutions. So our solution to that is infinite. I still don't know why I have the word example attached. Okay, I fixed that. So take a minute in Desmos and graph this next one. Take just a minute and graph it and see if you can come up with a solution for it. Okay, so I have graphed this system here. And so hopefully you got the same thing that I got for this. But if you typed both equations into Desmos and you looked for that point of intersection, that point is right here. According to mine, the point of intersection is 0, 1.5. So that would be the solution to this system. So I'm going to go down here and I'm going to write 0, 1.5. And what these solutions basically mean is that if we were to plug 0 in for the x and 1.5 in for the y in both equations would be true. All right, let's let y'all try the last one. Take a second, try that last one, and then you can check and see if you are correct. And notice that all the formats are different. So, like our first couple that we worked, the x and the y were both on the same side. The last one we worked, one of them had x and y on the same side, and one had just y by itself. This one they're both in that y equals mx plus b form. So it doesn't really matter the order that your systems are written in. Desmos will graph any of them. And so as long as you've got two equations, you should be able to find a solution to that system using Desmos. So take a minute and solve that one, and then we'll see if you are correct. Okay, I have typed in both of these equations, and this is how my graph looks. And so when I look for that point of intersection for these, my point of intersection is at 2, 3. So my solution is that ordered pair, 2, 3. Okay, so solving these systems using Desmos is really, really easy. As long as you're careful about what you type in, Desmos will give you the answers pretty much to any of these questions. All right, let's keep going. I want to show you how to graph a system. So some questions will ask you to give the solution. Some questions may ask you to graph the system. Now, luckily, we don't have to do a lot of work to come up with points that we can graph to make a line. We can use Desmos for that. So all you need to do is put the system into Desmos so that it creates a graph for you. And then once you have that, you're just going to find 2 exact points on each line. So to make a line, you need 2 points at least. So you have to find 2 exact points on the line. If you remember in the past, I've referred to exact points like that as stop sign points. And so what I mean by that is if you're looking at a coordinate plane, a stop sign point would be where grid lines intersect one another. So if you've got grid lines running this way, and pretend like those are straight, y'all. And then you have grid lines running this way. You don't have to draw this, by the way. Stop sign points or exact points would be points that fall perfectly on the intersection of those grid lines. Points you, for sure, without a doubt, know the value of. So, let me erase that back out. So, find 2 exact points on each line. Plot both of them. And then draw your line across the entire coordinate plane. The whole graph needs a line drawn across it, not just the 2 points. Plot both and draw the line, and then repeat that for the second line. Now we are going to graph a couple of systems. So if you have graph paper, go ahead and get that in front of you. If you don't, it's okay. We will sketch a rough graph using just a plain coordinate plane. It's not a big, or like just a drawn out coordinate plane. It's not a big deal. It would just be neater for you if you happen to have some graph paper on hand. Okay, let's go find one to graph. All right, so here I have a coordinate plane drawn. If you don't have graph paper in front of you, if you will sketch just a quick X and Y axis and number it 1 to 10 in all directions. If you do have graph paper in front of you, basically do the same thing. Sketch an X and Y axis on it, number from 1 to 10 in both directions. If you have graph paper that's already numbered, like you have something that's already got coordinate planes printed on it, and it's not numbered all the way to 10, not a big deal. We're actually only going to use about to 5 in either direction today. So that's fine if that's the situation that you're in. In fact, mine is numbered to 10, so I wanted yours to match. But if you just want a number to 5, that's good. So get that situated. If you need to pause the video while you do it, that's fine. And then we're going to graph this system. All right, so to graph the system, if you're not done, pause it, come back. To graph the system, we're going to pull up Desmos and let it create the original graphs for us. Now, there are other ways to graph lines, and you may remember from last year us starting on the y-intercept and then using our slope to rise and run. And you can still do that if you want to, if you remember how that works. But I just felt like that was a little more complicated for you guys to do from home. So I thought we might just use something a little simpler. But if you remember how to do that, that's great. So if I type this in, and look, to type that fraction. Hang on, why is this not typing? Oh, because I'm touching the wrong thing, just kidding. Y equals, to type the fraction, you just do 1 divided by 3. And then make sure you scooch out beside it before you put the x. The x does not need to be on the bottom. It needs to be beside the 1/3. So 1/3 x plus 2. And then my second one is y equals negative x minus 2. Okay, so when I ask you to graph these things, it's usually easier if you just do one line at a time. So I'm going to hide that blue line and just look at the red line for now. You have to find 2 points that are perfectly on a grid line or exactly on a point to be able to graph a line. Now, a lot of times, not always, but a lot of times, they'll give you 2 points because they're going to tell you the exact points where the line crosses your x-axis and your y-axis. They're going to tell you those intercepts. And if those intercepts are nice, pretty whole numbers, you can use them. If they're not, then you're going to have to go find other points that would work. But for this red line, for example, I can touch this point that's on that line, and it's at negative 6, 0. So that means that for this line right here, change that color too, remember? Should have made some more space there. If you could write beside that or something, that'd be decidedly better than what I'm doing here. We're going to plot negative 6, 0. And then I need a second point to make that line. And so they also give me the y-intercept at 0, 2. So those 2 points will allow me to recreate that red line on my graph paper. Now I'm going to turn the red one off and turn that blue one back on. And I'm going to look for the same thing on the blue one. So on the blue one, again, they give us some intercepts. This first intercept at negative 2, 0 is nice, pretty whole number. The second one at 0, negative 2, also nice, pretty whole numbers. So to do the blue line, I can graph negative 2, 0 and 0, 2. Or 0, negative 2, sorry. So now I have 2 points for each line that I need to graph. And I can come back to my graph paper and actually do that. If for some reason those points on the intercepts were not nice, pretty numbers, and that happens, then you can zoom in on your graph. Whoa, I didn't mean for that to tilt. Until you find other points that do work. So, like this one works, but so would this one, and so would this one, and so would this one. Anything that's on a nice, pretty intersection of 2 grid lines like that is a point that would work for you. But be careful, if you zoom in too far in Desmos, it'll start telling you like decimal values, and that might get confusing for you. So just be aware of that in case that happens. All right, let me zoom back out. I don't really need my Desmos anymore, so I'm going to move it down here. And now I'm going to recreate these, and I'm going to go ahead and warn y'all in advance that it's difficult for me to graph perfectly on my iPad screen with my hand. So we're going to do the best we can. But I'm going to start out. Okay, so to graph this black line, I'm going to start with a dot at negative 6, 0. So I'm going across here to negative 6, 0. I'm going to put my point right there. And I told you to number to negative 5, but I was wrong. We needed negative 6 for this one. And then I need my second point at 0, 2. Now, find something straight. If you don't have a ruler, just use the edge of a piece of paper or the edge of a notebook or the edge of the cereal box. I don't know, the edge of something straight. And you're going to connect those all the way across your graph. And again, I'm going to do the best I can with this because it doesn't always work out great. Okay. And so we're going to connect that all the way across in both directions. And I can't draw both directions at one time, unfortunately, so you have to just bear with me. But your line should look like that. Okay, so it goes through both points and stretches across your whole graph. Technically, it should have arrows on both ends because it would keep going forever in both directions. And then I'm going to graph my second one. So my second one is at negative 2, 0. And then at 0, negative 2. And then I'm going to do the same thing with that. I'm going to draw a line as best I can. That's not as best I can, but I can move it. Y'all can't. And then I'm going to stretch that across there. And so again, if I was looking for the solution to this one, the solution would be that point of intersection at -3, 1. But I just wanted us to be able to graph it at this point. All right, let's practice graphing one more. So what if we have this system? So y equals 1.25x minus 2. And then we'll do -5x plus 4y equals -4. That looks really bad. -5x. Y'all might can hear Jake watching TV in the background. I apologize if that's distracting to you. 4y equals -4. Okay, I feel better about that now with it typed instead of handwritten because my handwriting was terrible. So for this, we'll do the same thing that we did on the last one. Wrong, but we're going to pull up our graphing calculator, and I'm going to type the two equations in. So y equals 1.25x. By the way, if you want to try this yourself and make sure that or see if you can do it, feel free to pause the video and do that and then come back and make sure you were right. All right, and there we go. So there are my two lines. Now you might look at this and automatically know what kind of solution you've got. No solution. Because these don't cross at all, ever. But we need to graph these. And so I'm going to turn off one of them. I wonder if you want to change your color, you can change your color. So I'm going to change the blue one to match my blue. I'm going to change this one to black to match the one I wrote in black. Okay, so looking at just my blue equation for now, here it is. If I need to graph this, I've got to find 2 points that exist perfectly on a grid line. Now, this bottom point where it crosses my y-axis is a nice, pretty point. It's 0, -2. So I know for my blue line, I can graph 0, -2. But if you look for this one, the x-intercept is not pretty. 1.6 is not something we can graph exactly. So we need to find another point that does work. So what you do is you zoom in. I still want it to count by ones. I don't like it to count by. There we go. So I have this point here. But I'm going to keep going up my line until I find another one that does the same thing. Now see how this point right here is the same situation where two lines intersect to make that one. Two lines intersect also. Somehow I moved. I don't exactly know what went down there. Yeah, I don't have any idea what I just did there, but there we go. That's still in the wrong spot. Whatever. So I have two lines that intersect right here to form that point. So that's a point that we would consider a stop sign point, a grid line point. That point is at 4 and 3. So I can also graph the point 4, 3. So again, you had to pick 2 points that exist perfectly on your line. To be able to graph them. Now another option you have is to hit the settings wheel up here. And you can pull a table up of values. And you can choose some points that are perfect whole numbers. So like 0, -2 is on there. There's not more, but I can continue to work the table. So there's 4, 3. I could keep typing in numbers until I found more that worked. See, at 8, I have 8. I could graph that. So you can use that function if you want. But you don't have to do that. It's just an option. Okay, so that gets me the first one. The second one, let's pull it back up. And I accidentally deleted the other, but it doesn't really matter. So for the second one, I need 2 points for it. I have 0, -1 for one of them. But the x-intercept is 0.8, so I'm not going to want to use that. I got to go find something else. So that one worked here. And we'll go on up the line here. So there's another what I call stop sign point. 2 grid lines intersect, and the line is exactly through the middle of that. So that is 4, 4. So now that I have, and again, you could have pulled the table on that if you wanted to, and you do that by hitting that little settings wheel. Well, that one doesn't give me the option of a table. That's super weird. I don't know why. Well, don't rely on the table option. Trace your graph and find it. Okay, so we've got the points that we need. Let's go graph them. So I'm going to go to my coordinate grid. I'm going to plot 0, -2. I'm going to plot +4, +3. And then I'm going to connect them with a line and a straight edge. So a line. And again, your line should go all the way through your whole graph. Like that. And then I'm going to graph my second line at 0, -1. And at 4, 4. And if you remember from the picture, your lines should turn out to be parallel. And we know parallel means there is no solution. And again, both of your lines should have arrows at the ends of them. Like that. Okay, that's the end of our lesson for today. So now there is practice available for you in Canvas on this stuff. You can pretty much do all of it on Desmos. But there are a couple that require you to graph them, so just pay really close attention to where you're putting points. It's not real hard to do, but you just want to be exact about what you're placing on there so you can get your line in exactly the right spot. If you have questions, jump on the Google Meet that I sent you a link to, and you'll be able to ask your questions that way. Otherwise, this stuff is due by the end of day today. Y'all have a beautiful day. Thank you. Oh, don't forget to upload a picture of the notes you took on this lesson to this assignment before you submit it. Okay, thank you.